Hi, let's go ahead and continue with our next section, which is on slope. So let's recall what we learned in our last section. On this week's section, the first one that was posted was on lines. And we learned how to graph a linear equation in two variables where we have an x and a y. Now we're going to focus on a key part of our line, and that is the slope. Let's start off with the definition. The definition of a slope is the slope of a line denoted by the letter m is the ratio of the rise to the run. That is, the slope, the variable we like to reserve for slope in math is m, and that's defined as your rise divided by your run, or rise over run. It's often written in math as change of x over change of y. And that's what we see here. That triangle means change, and it means subtraction in our sense. The reason for the letter M is because in French, monter means to climb, and the slope is the steepness. So highlight this word. It's super important to our purpose for the section. The slope is the steepness. So yes, we learned how to graph lines, but every graph or every line we graph in our Cartesian plane has a level of steepness, right? It can be okay steepness, it can have a really, really small steepness, or it can be super steep, right? That is dependent on your slope. And here we have a picture. The way we're going to develop the slope is by using 2 points and finding the rise and the run. So point 1 and point 2. Now remember, we like to use x and y for our points. X comma y. With our points, to show that it's point 1, we're going to add a small subscript of a 1 to our x and our y. To show that belongs to point 2, we're going to add a small 2, a subscript of a 2. And we'll refer to those points. For point 1, we'll say x1, y1. And for point 2, we'll say x2, y2. Example, plot the points -1, 3 and 2, -2, and draw a line through the 2 points. Find and interpret the slope of the line. All right, so I drew a pretty big grid. I didn't fit on the previous page, so you can easily find these points and plot them and find the slope. So I have -1, 3, -1 up 3, 1, 2, 3, and 2, -2, 2 down 2. Okay, we plot them. We drew a line across them. Now I want to find my slope. Your slope is defined by your rise and your run. So I go across your run, that many points, and our rise up and down, we're going to count how many units is that way. Okay, we see that for our run, we have 1, 2, 3 units, 3, and think of your number line. From 0 to the right, you have your positive numbers, to the left, you have your negative numbers, right? And on our vertical line in our Cartesian plane, we have 0. Above, we have positive numbers, and below, we have our negative numbers. So let's attach that same sign. So we ran to the right 3, so we can write a +3. Now our rise, from this point, we're going to go 1, 2, 3, 4, 5, 5 units, and we went down, right? So let's add a -5. We now have the ingredients for our slope. We know our slope, m, is made up of our rise over our run. And what numbers do we have? For our rise, we have +3. And for my run, we have -5. So what is our slope? Well, it's a fraction 3 over 5. And a positive divided by a negative gives a negative, so we can write a negative 3 over 5. Now, a question I always get when we talk about slopes and fractions and negatives is where do I put the negative? And I know you might think, oh, I'll just write in the middle, just to be on the safe side. And that's okay. Let me give a small little note on working with negatives and fractions. It's a little sidebar, a little note. Let's think of a number that's negative. Let's say negative 2. Now, let's think of a number that gives us negative 2. So 6 and 3. 6 divided by 3. Okay. What is negative 6 divided by positive 3? You get negative 2, right? Next one. What is positive 6 divided by negative 3? Again, we get negative 2. And what's the negative fraction of 6 over 3? We still get negative 2. So it doesn't matter where your negative is, as long as it only happens once. It can be in the top, it can be in the bottom, or it can sneakily be, in a very sneaky way, be written in the middle. And that's not sneaky at all, it's totally fair. But as long as one of our numbers is negative, or our whole number is negative, then our answer is negative. And thus we would have a negative slope. Okay, you try it. Plot these 2 points and find the slope. So go ahead and pause the video so you can give yourself plenty of time to work this out. Once you're done, unpause the video so we can work it out together. Okay, let's go ahead and see what we got. So let's plot our point. 2 up 3 and negative 7 up 4. All right, let's draw a line across it. That one's not very steep, right? Let's count our rise and our run. So from one point to the next, I just go up 1. So and let's connect it horizontally, right? And that's going to be our run. So we have our run and our rise in red. Let me zoom in. Okay, now when you're working with math and slopes and lines, just like reading, you want to work from left to right, like if you were reading. So let's go ahead and start with our rightmost point. Okay, let's count how many units it is for the run. We're moving to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units to the right. Because we moved to the right, it's positive. Let's count our rise. From there, we're going to move down. Down just 1 unit. Because we moved down, it's going to be a minus. So let's write our slope. Our slope, our rise over your run, is made up by, we have a rise of negative 1, and we have a run of positive 9. So my slope is negative 1 over 9. Let's move on to the next one. We have 2 up 7, 2 up 7. No, that's negative 2. We want positive 2. And 3 up 10. So I have 7, 8, 9, 10. Ooh, that wasn't a good number for my behalf. Let's find our rise and our run. So I have my run and I have my rise. All right, let's count our units. Remember, we go from left to right. So I first have my run. I go to the right 1, so that's a +1. And then I'm going to go through my rise, which is a vertical movement. So I have 3 units. One, 2, 3. So I go up 3, a plus 3. Let's write our slope. Our slope is our rise over your run. So we have a slope of our rise is 3 and our run is 1. So 3 over 1 is just 3. We have a slope of 3. I never did connect those points. Let's go ahead and connect them. Okay, so here I have these empty grids so we can write the types of slopes. Our types of slopes are, we can have a negative slope, a positive slope, an undefined slope, which is a vertical line, and a slope of 0, which is just a horizontal line. So a negative slope, it goes down from left to right. A positive slope goes up from left to right. And if you're unsure, I always think of a person walking and they're going down the stairs, or are they going up the stairs? That's what a slope is. Now, an undefined slope is a vertical line. And think of a number that's undefined. So if we have any number divided by 0, that's an undefined statement. So next we're going to learn how to find the slope algebraically so that we don't have to plot points and do rise over run each time. There's a formula that we can use. And if we so happen to get a 0 in the denominator, these two lines will create a vertical line. And a vertical line has an undefined slope. And lastly, we can have a slope of 0, which is from a horizontal line. When you try to find the slope of a line algebraically, if we have 0 over a number, well, 0 divided by any number is always 0. So a slope of 0 gives you a horizontal line. And we'll see an example of that soon. All right, let's go on to our definition, the equation of a slope. Given the point x1 and y1 and point 2, x2, y2, the slope can be found by the equation below. So highlight this. It's going to be very helpful. Y2 minus y1 over x2 minus x1. Okay, let's go ahead and use the points we graphed to find the slope. Let's try to find the slope now algebraically. Okay, so pause it, give it a try, and then when you're done, unpause it so we can work out together. Okay, let's do you try A. So we're going to use the slope of a line that we have written up there. Okay, our equation is m is equal to y2 minus y1 over x2 minus x1. Now, at least for the sake of me not doing a mistake, I like to label my points. Point 1 is x comma y, so I'll write x1 and y1 to show that it's point 1. And point 2 would be x2, y2. That way I can easily plug in my numbers because I know which one is which, right? You know x1 is 2, y1 is 3, x2 is -7, and y2 is 4. Let's go ahead and substitute them into our equation. So y2 is 4 minus y1 is 3, x2 is -7, and minus x1, 2. And we're left with 4 minus 3 is 1. -7 minus 2. We have subtraction with a negative. Remember, you always add the opposite, so we get -9. And that's our slope. Our slope is -1 over 9. All right, let's go ahead and do B. just like before, I need to label my points. So I have x1, y1, x2, y2. And let's write my formula. M is equal to y2 minus y1 over x2 minus x1. So y2 is 10, y1 is 7, x2 is 3 minus x1 is 2. 10 minus 3 minus 7 is 3, and 3 minus 2, we get 1. So we have a slope of 3 over 1, we get 3. That's our slope, our m. Okay, let's do 2 more examples. These 2 examples will be our funny situations. So these undefined slope and the slope of 0, just so you see how those look. Find the slope of the 2 points. So let's label our points. I have x1, y1, x2, y2. And our equation is m is equal to y2 minus y1 over x2 minus x1. All right, y2 is 3 minus y1 is negative 1 over x2 is 2 minus x1 is 2. All right, so 3 minus negative 1, turn to positive. So we're left with 4. 4 over 2 minus 2 is 0. Uh-oh. We have a 0 in the denominator. So this means it's undefined. When it's undefined, we know we have a vertical line. So we can just say that our slope is undefined. And if we get an answer of undefined, we know not to be worried. We know it's just going to be a vertical line. Okay, let's go ahead and work out B. Okay, so my point 1 is x1, y1. My point 2 is x2, y2. And my formula is m is equal to y2 minus y1 over x2 minus x1. All right, y2 is 4 minus y1 is 4. Uh-oh, we see something funny going on already, right? And x2 is 3, and x1 is minus negative 2. 4 minus 4 is 0. 3 minus negative 2, we get 5. And 0 over 5, we get 0. Having a slope of 0, it's okay. We know that that just means that it's a horizontal line. Moving forward, let's do one more example. And this is getting us ready for our next type of problem. And we'll continue this on the next week, on our Tuesday lecture for next week. Draw a graph of the line that contains the point 1, 3 and has a slope of 2. Okay, well, I know the slope is a steepness, right? So how about I use my steepness, which is your rise over run, that we're given of 2. So I have 2 to rise a fraction to have rise over run. We can write as over 1. Let's use my steepness from my point to create another point. So I have 1, 3, so 1 up 3. Now if I wish to find another point, let's use our slope. We have a rise of positive 2, so I'm going to move up 2. And I have a run of positive 1, so I'll move right 1. So let's go up 2, 1, 2, and let's go to the right 1, 1. So I can go ahead and have a new point. Let's go ahead and count again. Go up 2, 1, 1, 2, and go to the right 1. and that gives a new point. So now we have a line. We can go ahead and draw points through our line. Here's how you can find a line given a slope and a point. So we graphed it using, first, the point, and then second, we use the slope to draw more points. Okay, this will prepare us for our next section. We won't go too much in depth into it, but I just want to go through enough so I can tie it to a statistics topic. Okay, that's it for this section. If you have any questions, please email me or post it in our discussion board. Thanks.